point is that as we realize that it's all one water, it's just cycling. And so that's where we at the Program for Resource Efficient Communities, that's our bread and butter, is to try to work with developers on how to effectively implement this transition to these kinds of landscapes that don't require the water resources.
What that tells me is that we're building biodiversity from the ground up.
Literally.
Literally, from the ground up. Hello, friends. In this episode of the Ground Up podcast, I speak with Dr. Pierce Jones. Dr. Jones is a professor at the University of Florida and the director of the Program for Resource Efficient Communities, where he has been working over the past 30 years to promote the adoption of sustainable land development practices in Florida, working with large-scale private developers as well as research institutions and state agencies.
Good.
Well, Pierce, welcome. Thank you so much for doing this podcast with me. Really excited about this, actually. I always enjoy speaking with you, and I'm excited to share your thoughts and ideas with our audience, and so thank you.
Happy to be here. It's a delight.
Why don't we start out with, tell us a little bit about where we are.
We are in Micanopy, Florida. We are on the west side of I-75, about 1 mile from the interstate, which you may be able to hear in the background a little bit. This is a piece of property that my wife and I moved to in 1978 when I was a graduate student at the University of Florida, and we've lived here ever since. We didn't, when we moved here, think we were going to be here all that long, but it's just continued and continued.
And here you are.
And here we are.
Well, it's a beautiful property, and it's also a working farm.
It is. I've always had cattle, primarily for tax reasons. You have to have cattle or pine trees. That was the basic rule of thumb for property tax purposes. But it has evolved into perennial peanut production, about 22 acres of perennial peanut, which you can see in the background. It's EcoTurf is the variety that we have planted. Unlike most people that grow EcoTurf, I turn it into hay for my cattle. And the idea is to have a local source of protein as opposed to bringing in corn or molasses or other sources of nutrition for the cattle. And then I sell those cattle locally in the Gainesville area, people that want to buy half of an animal. We have a local butcher that we take them to. So that's how I'm currently using the perennial peanut. And it's working out quite well. The cattle are quite happy, and the amount that I'm able to produce on these 22 acres is enough to support a herd of just under 50 animals. And so that's where we are and what we do.
So it's 22 acres of perennial peanut?
Correct.
And it supports 50 animals?
Yes, I do buy Bahia to supplement the perennial peanut. Perennial peanut is such rich feed that you can give a bale of Bahia one day, which is much lower in nitrogen and protein, and then a bale of perennial peanut the next day. The period of time, and really you don't have to start feeding them hay until maybe January. This year I think I started right around Christmas feeding hay. Other than that, the pasture is enough to support them.
That's wonderful. And perennial peanut, a lot of people may not know, it's a superfood for cattle.
Yeah, I didn't know that, but I know that they like it. I know they love it. They come galloping when I bring them a bale.
Yeah, because it's very high in protein.
High in protein.
Mm-hmm.
I would say between 13-15% protein content, which is very good. Bahia, fertilized Bahia, maybe a 7.
Mm-hmm. So you kind of have an integrated farm system here.
I do.
really a closed loop. You're growing the forage, you're raising the cattle, and the cattle is butchered on site.
It is. That's true.
Yeah.
Yeah.
Well, it was a real treat last night. You and your wife Laura invited us to dinner, and you served us some beef that was born and raised and slaughtered here, and fed perennial peanut.
It's all true.
It's all true, and I can't think. Grass-fed beef sounds very appealing. That's probably superior to industrial farm cattle, but cattle that is raised on a perennial peanut farm that you eat on the farm, I think that's about as close to as eat local as you can get.
That's our hope. That's our hope.
It was delicious.
Thank you.
Very, very, very tasty.
I think the cook had a lot to do with that.
Yes, Laura was such a treat. I really enjoyed meeting her last night, and we'll talk a little bit more about that later. But staying on the topic of perennial peanut, it really is a superfood for cattle, and in my opinion, it's a super plant.
Yeah.
And we're using it in the ornamental landscape business to provide a turf alternative that is drought tolerant, that requires very little mowing, that can thrive with no irrigation,
Yep.
and that blooms.
Yep.
So those are some pretty nice characteristics that are significant advantages over St. Augustine or Zoysia or even Bahia.
And the fact that it fixes nitrogen.
Correct. It's a legume.
So you don't need to apply highly mobile mineralized fertilizers, which I think is important. And Florida soils my soils are naturally phosphatic, so no phosphorus needed. The only fertilizer I ever use is a little bit of potassium in the form of K-Mag, because it has micronutrients with it, and so that is one of the external inputs, but K-Mag is actually manufactured here in Florida. I would prefer not to be using it, but...
So that's it. You get the phosphorus from the naturally occurring deposits in the soil.
Yep.
You're getting the nitrogen from the legume itself.
Correct.
And you're adding K-Mag potassium.
Right.
So in a landscape setting, if we're not concerned about feeding cattle and we're trying to save water,
Right.
perennial peanut is an excellent alternative to turf, and it's being adopted more and more widely.
Yep.
It's been present in the landscape industry for decades, but I think now we're seeing people really gravitating towards this as an option. It works great in medians between the sidewalk and curb. Any areas where you have a small area where you would otherwise use turf, it's a great alternative because, again, you don't have to mow it.
Right. Right. Yeah, you don't have to. I mean, my daughter's got it in the area between the curb and sidewalk at her house, and it will top out at maybe 10 inches, so it's like mounded, but it stops. It doesn't keep going. Mm-hmm. And another point, if it's used in that application, I don't think you need the potassium, because if you have a good, healthy biome in your soil to recycle, if you're not harvesting and taking the potassium away, I take it away and give it to the cattle. So that's why I have to add that back in. But I don't think in a residential landscape that you would necessarily have to have any potassium.
Probably not. And I think you can get away entirely from mineralized and synthetic fertilizers with the combination of legumes such as the perennial peanut and compost.
Yes.
And between those two sources, you should be able to get all of the nutrition that you need.
Absolutely. And I just think that it's the other things that I like about it. This is land that we're on is, if you look at the USDA, if you looked at the USDA maps, it would say that these are marginal soils for agriculture because they're very erodible. And once the perennial peanut gets established, the root mass is so like spaghetti. If you take post-hole diggers into that field, it will look like spaghetti 8 inches down. And so once it's established, it's very good for erosion control. Another thing I like about it is that it absolutely plays well with any other plant material. We have a lot of, not a lot, but Bermuda grass growing in the field. It came in from hay that I had. And cattle, of course, love that too. So from hay production perspective, it doesn't do any harm. But it does not have to be a monoculture.
It mixes well. We've been exploring different ground cover mixes with perennial peanut, including sunshine mimosa,
Yep.
which is a native legume that provides some of the similar benefits. And it has a purple bloom,
Yeah.
as opposed to the yellow bloom of the peanut. So you get into some pretty interesting aesthetics. But we've also mixed it in with the dry twin flower, the wet twin flower, coreopsis, and so there's a lot of diversity that you can promote with those types of mixes. And I think the blending of the ground covers provides some additional resilience ecologically, and it lowers your maintenance requirements because the plants are collaborating in that diverse system to colonize the various niches within the soil profile. So even in a small area, you could have some differences in soil moisture and soil temperature and sun exposure, and those subtle differences will cause a single plant to perform very well in one spot but underperform in another. People might look out at their lawn and notice, oh, there's a brown spot over there, or there's an area of my lawn I just can't get to look as nice as the rest. And it's very likely because of some of those micro differences in the soil and the climate. When you have a mix of species, they work together to properly find their niche and cover the entire ground. And that's a very effective strategy for competing with the weeds.
Mm-hmm. Absolutely.
So not only do you not have to mow, but now you put yourself in a situation where you have very little to no weed pressure.
Yeah.
And we're getting into a scenario where you can maintain a very attractive landscape, including, lawn-like ground covers, that essentially has very low to no cost of maintenance.
Exactly. That's exactly right. And yet, if you want to mow it, it's after the mowings that the little yellow flowers just pop up anytime in the spring through the summer, early fall. So you can mow it if you want to. I said my daughter's, it mounds up to maybe 10 inches tall. If you needed to mow it in certain areas more frequently, it works well in that. In fact, I can show you on the other side of the barn. My wife tends to mow around the barn very tight. And what happens is the leaf just gets smaller and smaller and closer to the ground. So it can adapt to whatever the mowing regime is. Mm-hmm. And so, by the way, I do want to clarify, I'm definitely not an expert on perennial peanut. I simply have experience with this pasture. But Ann Blunt at the University of Florida and other folks have much better information than I might have on this. But my experience, and I can confirm what you said about the weeds, I make very little effort at controlling weeds in these pastures, and you can look at them and they're
very clean.
They're very clean, and it's not because I'm making a major effort to do it. The one thing I would say that we did do was before we ever planted, we hit it hard with herbicides to eliminate the pressure when it was being established, and it was a little slow to establish. It's in the second summer that you get any possibility of cutting it for hay. Third summer, it's pretty filled in. It's pretty good.
Yeah.
So it's slow to establish the way I planted it, but I sprigged it in.
And it's not irrigated.
And it's non-irrigated.
So when you establish it with quarts or 1 gallons or in sod form, and you have irrigation for establishment,
yep,
we found that you can establish perennial peanut in 3 to 4 months of a growing season.
Yeah.
Which is actually a very good result. And once it's established, because as you were saying, the depth of those rhizomes, which continues, even post-establishment, that depth continues to deepen, that is a very formidable weed barrier.
Yeah.
Because of the way that they intertwine, and the rhizomes can be thick, almost like a spaghetti, or almost as thick as your finger in some cases. So that is a very effective way of not only preventing weeds from penetrating up through the soil, it's also a great way to stabilize
Yeah.
soils on slopes and banks.
That's been amazing, because when I was going through establishment on the north slope of that field to the east, I had big erosion problems. We had some 6-inch rains, and I had some big erosion problems. I had to take the backhoe and backfill these channels up the hill. But now the peanut has grown in. We've had 6-inch rains, no erosion. So it's been very effective once it's established. And of course, other flatter, this is a very hilly area that we're in. But once we get into flatter areas, of course, that's not really an issue. Also, I was going to say that when it's happy, being a broadleaf, it will shade also. You don't get much sunlight for weed germination. And the weeds really, if I said 10 inches of that thick material, it's very hard for a weed to compete. So without any chemicals, no herbicides are needed.
Mm-hmm. So this is why we're using perennial peanut in citrus groves, which is another very interesting application of the plant for Florida. In citrus, we've been combating citrus greening, and we believe that a large part of the challenge with citrus greening is the lack of resilience in the soil, because we have a history of farming using a lot of chemicals,
Yep.
a lot of herbicides, pesticides, and synthetic fertilizers. And that has had the effect of depleting the life in the soil.
Yeah.
There's in fact a lot of life in healthy soil because of the abundance of microbiology, microbes, fungi and bacteria. There could be billions of organisms in a thimbleful of healthy soil.
Yeah.
And those organisms are very important to providing services to plants, helping them to mine nutrients out of the soil. So for example, that phosphorus that's in the soil, the plants can't access that phosphorus on their own. They actually require the services of microbes to help them mine and break down these phosphorus molecules into forms that they can take up. The microbes actually will transport the nutrient to the root tip. So this is all microscopic. Most people may not be aware of those functions, and frankly, we as farmers may not have been aware, or certainly we were not mindful of that, because the practice of applying herbicides is very toxic to the microbiome. And as a result, our trees were very vulnerable to the citrus greening disease, which came through the state and ravaged the industry. We literally went from 1 million acres of citrus in Florida to today, perhaps there's less than 200,000 acres in 20 years. So now we're trying to reinvent citrus farming and find ways to grow citrus despite this devastating disease. And our growers believe that we need to return to more traditional farming practices, which respect the role and importance of a healthy soil, which is rich with biodiverse life. So to do that, we have to identify ways to reduce the use of herbicides.
Yep.
And the tactic that we've settled on is to plant perennial peanut in the row middles.
Yeah.
That has the advantage of, as we talked about, preventing weed growth, so we don't have to herbicide, and on top of that, we don't have to mow.
Right.
So we will be saving money as well as reducing chemicals. And it has the additional benefit, as we've mentioned, of fixing nitrogen. So our citrus trees require about 160 pounds of nitrogen per acre. And it turns out that when you use ammoniated nitrogen, which is the synthetic nitrogen that you can get from chemical companies, which is fixed using the Haber-Bosch process,
Right.
that form of nitrogen is also toxic to the soil. It will kill the microbes that have colonized your soil if you apply too much of it. Well, it turns out we can get 40 pounds of nitrogen from peanut. At least that's what we're expecting. So that's a quarter of what we need, and we're also getting about 40 pounds from compost, so we're halfway there.
Yeah, yeah. Well, and you mentioned compost. I think that kind of a revelation for me in the last 5 or 6 years as I've been working with compost folks. And I think in the beginning I just thought, well, this is a smarter way to recycle. And I think I was interested in what happens to biosolids from wastewater treatment plants and things like that. But it took me a long time to recognize the benefit of the biology in the compost. And now I'm extremely interested in that. And in fact, at Compost 2024, which is the international meeting that happened in maybe a month and a half, 2 months ago, I met a geneticist who is actually doing the DNA on all of the microorganisms that are in the biology that's in the compost. So she can actually map, so compost, one compost product versus another compost product, that's going to become significant as how we tune, not that we'd have to go to great lengths to do it, but I mean, I want to know that you in fact do have that robust biology in the compost. I think that that's as important as the water holding capacity, the cation exchange capacity, all those other benefits from the compost. The biology is just huge, I believe. I'm ignorant in this area, but that's, as a cultural practice, a horticultural practice, I think that that's going to become a more widely recognized benefit, aside from just the nutrition that compost can provide, water holding capacity and all that. I think the biology is maybe the most important aspect of it.
It is, and I think when we talk about returning to traditional methods of farming, farmers have known for millennia that we need rich, healthy soil to farm in, and farmers have always sought out the most the darkest, richest, carbon-rich soil,
Yeah.
and they've always put manure back onto fields, and this practice is in fact a way of enriching the biology in the soil. Now, whether or not farmers 10,000 years ago understood what we understand about microbiology, probably not. But the reality is a lot of our medicines come from microbiology. Mm-hmm. And a lot of the most advanced biotechnology today is coming from discoveries in the realm of microbiology, which is to say identifying particular strains of bacteria or fungi that have particular properties that we can harness for human use and agricultural use. So the idea that we can build soil biology with compost is very important. And not all compost is the same, as you were saying.
Right. That's the thing that I'm most interested in now, is to see that industry move forward. And of course, they've got certain things that the U.S. Composting Council is requiring, and that's a good start to make sure you've got mature, properly managed, properly delivered compost, because immature compost can be actually a detriment in an environment. As I understand, that's what I've understood. But I think that the refinement in that product is going to be very beneficial agriculturally. And of course, I think what you're saying is that once the farmers understand this relationship better and can actually pencil it out and see the economics. Of course, with greening, you either have a crop or you don't have a crop. I mean, that's one thing. But then beyond that, even, how well can this practice perhaps be brought to bear to, again, close loops? And I mentioned the biosolids from wastewater treatment. That's a huge problem, and there are people are going to flush toilets. We have got to do something with the biosolids, and there are a lot of solutions that I don't think are quite reasonable. And I think the idea of compost on a huge scale, with that product not just being a waste stream that's been more or less captured, but instead a valuable product that's been manufactured from that waste stream. I think that's a great potential future for both the agricultural industry and also residential landscaping and elsewhere.
Absolutely, and the biosolid issue in Florida is a real issue. It's literally piling up with nowhere to go, but but downstream, and downstream means our lagoons and estuaries, and that's where we see the algal blooms. So we have to shift our mindset from linear mode of thinking where things start at the beginning and flow linearly out to the end, and now start to think in circles and cycles.
Exactly.
Which is the way of nature. And when we capture the biosolids into a composting process and reapply that compost back onto the farmlands to enrich our soils, we are building the biology, of course. We're also building up the organic matter
Yep.
and the carbon in the soil. And there are a lot of benefits to that.
Absolutely, absolutely. And there are farms that have gone to this regenerative farming practices. White oak up in South Georgia or South Alabama, I can't really remember. It's
I think they're in Georgia, White Oak
yeah,
Pastures.
Yeah. They've actually been monitoring, they've been doing this for enough years, and they've been monitoring the carbon content, the organic matter content, and they have steadily increased that content. So they've gone from a traditional agricultural practices using the chemical fertilizers and so forth, where they depleted the natural organic matter levels, and now by using the methods that they are with regenerative farming, they've steadily increased that. That also becomes a carbon holding scenario, a carbon fixing scenario, which I think has also got good benefits on a global scale.
Exactly, because as far as the technologies for carbon sequestration, I'm not aware of any technology that is superior to sequestering carbon in the soil. And that process is very natural, where the plants are breathing in the carbon dioxide from the atmosphere, and through the process of photosynthesis, they are creating carbohydrates or sugars, which are the basis of all life, energy, and food on the planet. That carbohydrate that's formed in the leaves by the plant's photosynthesis is going to be translocated through the trunk and the stem of the trees down into the roots, where the plants are engaged in this reciprocal relationship with the microbes. And what they're using those carbohydrates for primarily is to feed the microbes in exchange for those services.
Exactly.
So as we were talking about, the microbes are going out and they're literally mining the phosphorus and the potassium and the manganese and the other minerals out of the soil, and they're transporting them to the root tip. So they're working quite a lot on behalf of these plants, and they're not doing it for free.
Exactly.
They are requesting payment in the form of carbohydrates. They're called exudates. And I think of exudates as carbohydrate cakes. And so the microbes actually, each microbe has a different recipe that they prefer. And so the plant, depending on what it requires, will bake a cake of a certain type, and it'll set it out on its root tip. And that attracts the microbe who, in exchange for the carbohydrate, is bringing the services. Now, the microbe will then eat the carbohydrate cake, the exudate, and incorporate that carbon into its body, into its skeleton, and and when it dies, that becomes part of the soil, and that carbon is now locked in and trapped into the ground. And as there's a tremendous quantity of microbes in the soil, as we talked about, billions per cubic centimeter, that process is happening continuously. But it only happens when you have organic matter and healthy soil. So the more we invest in our soil, the more we promote the carbon sequestration capacity of the land, the ground that we're on.
Yeah, exactly. And that's interesting to think of it in those terms, and that makes me think about what's happening in our land development processes, where we now in almost all land development projects, there is a contour map of a site that is not anywhere near what the site looks like when you start the process, and that results in moving a lot of earth, and the topsoil is the soil profile is completely disrupted. Anything that layer that would include the biome, the soil microbiome, would be lost. You can try and capture it by stockpiling topsoil and so forth, but frankly, it's just, you've totally disrupted that system. And then we come in after we've graded out these lots with this very pure organic matter-free soil material, and we try to put a landscape on top of it. And I think that's one of the big benefits to adding the compost into those residential landscapes. And so I'm very happy to see a lot of locations in Florida, both developers, private developers, and local communities looking at soil amendment use as a kind of a required practice. Because it's not free, you do have to pay for it, but the longer term benefits I think are tremendous from giving the landscapes a good start, and you don't then have to treat them like a hydroponic system that needs a lot of nutrition in the form of these mineralized fertilizers that you talked about, and then irrigation, of course.
Yeah, and the water holding capacity of compost is a real important factor in Florida, specifically because we have such sandy soils and we have such population growth, and we're getting to the limits of our water capacity.
Yep.
And now we need to find ways to be more efficient with our water use. One of the ways to be more efficient with our water use is to increase the organic matter and carbon content of soil, because that serves to soak up water that falls on the landscape, whether it's through rainfall or irrigation, and it holds it in the soil profile around the root zone for a longer period of time.
Right.
So we're extending the hydro period of that soil, which means that the roots have more time to drink, as opposed to when the rain falls, the water just goes right through the sand like a sieve, and if the roots aren't able to uptake in an instant, that water's gone.
Exactly.
And the compost holds 6 times its weight in water. So that's another benefit. So we talk about, you mentioned the cost of applying compost, and they certainly are important to consider. But you have the benefit of reduced fertilization, the benefit of reduced irrigation, and I think eventually on the horizon we'll have the benefit of carbon sequestration, which should be something we can monetize through carbon credit markets. But back to the fertilization, I just want to point out in citrus, we are currently applying 8 tons of compost to the acre. And we're doing this on a scale of about 5,000 to 6,000 acres every year. That's a lot of compost. And what we found is that we get, I believe we can get about 40 tons, 40 pounds of nitrogen to the acre from this compost application. And the cost of applying the synthetic nitrogen at 40 pounds to the acre is about equal to the cost of applying the compost. Mm-hmm. So it's a wash.
Yep. I didn't realize that.
So it is currently a wash. So that's an easy decision to make. We don't need carbon sequestration, carbon credits. We don't need any other water savings to justify the practice economically as a farmer. But in addition to the nitrogen, we're getting all the other benefits of compost, right, which all of the other, we're getting potassium, we're getting phosphorus, we're getting all of the micronutrients and all of this biology, plus the carbon and the water holding capacity. So it's clearly, for us, it's an economically viable and sound practice. In fact, knowing what we know now, I would say it's unsound not to do it.
Right. Then the question becomes, as demand for the compost ramps up, will we have sufficient compost production? And I think we will. I think we can match that. But a little bit of chicken or egg, while the industry ramps up and to produce the compost, we've got to hopefully create the demand. We use the compost on all the sports fields at the University of Florida. I know that Disney on lots of their sports fields and golf courses are using compost products. People have realized this for quite some time. The managers of these facilities have realized how beneficial it is to the resilience of the material, like on the Florida field when they play football. You have to have, occasionally you've got a game one weekend following the next, so 7 days to recover that field. And I know that the managers feel that the compost is tremendously helpful to them.
It is, and resilience is simply the ability of an ecological or biological system to respond to stressors.
Yeah.
and to adapt to various types of stress. So a football game on a turf field.
Right. It's a pretty good stressor.
Put yourself in the position of that plant, if you can imagine yourself to be a blade of grass. Those are big, heavy guys.
Yeah, they are.
With cleats.
With cleats.
And so every weekend they're pounding that grass. Well, people who are responsible for managing the turf grass, they probably get a lot of heat from the university if it doesn't look good, I would imagine.
They do.
There's a lot at stake. So what they found is that applying compost is a strategy for resilience. And that's also what we're finding in citrus and what we're finding in ornamental landscapes. And I'm encouraged because we can have this conversation, you and I, today, and realize that it's spreading throughout the state of Florida, throughout different sectors of society, where people are realizing that the use of compost, the use of cover crops and legumes like perennial peanut are very attainable and sound strategies for creating resilient landscapes, resilient crop systems, and resilient ecosystems. And I think we couldn't have had this conversation 10 years ago. It would have sounded very foreign.
Yeah. When I first moved out to this property, I had come from Tennessee, and I was aware that in the north you have so many, in Kentucky and middle latitude states in the United States. In April, it's still kind of winter, but there are these clovers and other rich forages that will grow in those cool weather conditions, and very nutritious. Of course, clay soils, that helps as well. But I was always amazed that here in Florida, in the months of April and May, I'm having to feed hay. Plenty of sunshine, no rain. And the same thing happens end of September, October. And so here I had plenty of sunshine, but I could either irrigate, which doesn't make economic sense for just, beef cattle operation. But I had grown Alice clover, I had grown red clover, crimson clover. I've been trying all these legumes since we first moved out here. And it wasn't until I found the perennial peanut that I realized that we, finally had something that would actually really thrive here. And it is thriving. It just loves it here. Drought tolerant. Those rhizomes are stabilizing the fields. It's just a tremendous crop.
So I think people listening so far might get the impression that you're a full-time farmer, but that's not the case.
No.
Tell us a little bit about what your real job is.
Well, it's definitely not the farming that pays the bills, in my case. This is a very, very tiny operation. It's effective. It does have revenue. It has expenses and revenues, which, if in a good year, they equal one another, so I don't have to spend more than I make. But my day job is at the University of Florida. I direct the program for resource-efficient communities. We are interested in land development in Florida, specifically residential master plan communities, is where we're most involved. And in those communities, we have been interested in lots of issues, everything from energy to transportation to natural areas management. But the key issue, and the one that's of most importance to the developers of large master plan community projects, is water. And that goes back to something you alluded to earlier, and that is that most projects, essentially big projects, have a water budget. And that's in the form of some piece of a consumptive use permit, which is how much water a water utility or an agricultural operation is permitted to withdraw from the aquifer. And once you establish that budget, then you can go down from that to all of the different uses and roll them up and see if, in fact, once you've built out this community, will it, in fact, come in under budget. Now, politically, lots of times the budget's set, but it's broken. Nobody pays attention. It's a fiction, really.
So there's no consequence for using more water than you have allocated?
In the past. But we see all these little instances. For example, reclaimed water from the city of Claremont. There's actually a cap, even at residential neighborhood homes. there's a fixed amount that they can take now. It's not unlimited. There was a time when utilities were trying to give away reclaimed water, literally give it away, no charge. And homeowners were then, I know here in Gainesville, GRU used to give water away. And then they said, oh, well, we can't afford to do that anymore. It's too valuable. And they started charging, I think, $10 a month. Like that was the maximum. And people were just, I'm not paying $10 for that water. And they were going to put down their own wells instead of paying $10 a month for reclaimed water. But the point is that as we realize that it's all one water, it's just cycling. The utilities are coming to realize that if we don't use this judiciously, we are going to pump so much water that we start creating these concave drawdowns, even in the aquifer, that can lead to wells going dry in a period of time. I know that's happened in north of Gainesville in some areas where people's wells are going dry because of the water that JEA was pulling to take to Jacksonville. And so I think that this budget question, I mean, it will come to bite us at some point. And whether it's going to be sinkholes that happen when you're trying to protect the strawberries in the winter in Polk County, or whether it's going to be JEA overdrawing the aquifer in drought periods and affecting people in North Florida. We've got to basically get this under control. So as everybody has come to terms with this, it's become pretty critical that a developer with a big project with a long build out, that they strategically preserve their budget for the later projects, the later neighborhoods in a big project. And so that's where we at the Program for Resource Efficient Communities, that's our bread and butter, is to try to work with developers on how to effectively implement this transition to these kinds of landscapes that don't require the water resources.
So there's a water problem, shortage, I guess we can say, in Florida. But most people think of Florida as a place with a lot of water. We get 54 inches of rain a year. When I think of water crisis, I go to California,
Right.
Morocco, dry places under severe drought. Chile has a water problem. But those are all desert climates that don't get very much rainfall.
Correct.
But we actually have a water problem in Florida despite all of this rainfall?
We do because of timing. I mentioned earlier that, here with this farm, you would think that in April, May, with all the sunshine and 54 inches a year, why does my pasture dry up? Why am I feeding hay in May to my cattle? Because when we get a rain, it's not uncommon for us to have a 6-inch rain event. I mean, it happens in Florida pretty regularly. That's extremely rare in other areas to get those big rain events. Well, 6 inches out of your 54 or 53 inches per year, all at one time, it doesn't do you any good. And you can't store it. Well, where you actually do store it is in the aquifer, if it gets to the aquifer. It doesn't go out in surface waters. But the beauty of the aquifer is that it does serve as sort of the capacitor. It's the backup. But it doesn't mean it doesn't mean you can't run that battery down, and that's what we're doing by over pumping from the aquifer, and all those consequences like the sinkholes and so forth. Those are direct results of over pumping. So why are we over pumping? Well, it goes back to the soils in the neighborhoods. It goes back to if you go to traditional neighborhoods built before we went to slab on grade construction and went before we had the contour mapping and the disruption of the soil profiles. You could actually get a turf landscape established in a site-built home where you didn't disturb the soils, and the nutrition was there, the biology was there, a little bit of organic matter was there, and so you could get a little bit of a lawn started if that's what you wanted. But generally, you didn't clear more trees off a lot than you needed to build the house, and you didn't disturb the soil except where you built the house. That's not what we do now. We clear everything and we disturb the soil everywhere. So that's where we have to develop a different protocol that doesn't depend on the least expensive system on that soil without nutrition, without organic matter that's typically used in developments today. which essentially leads to a hydroponic system. You put that turf down, it brings in whatever organic matter is in the bottom of that turf. That's all it gets. You can then fertilize it with mineralized fertilizers, and you can irrigate it and effectively have a hydroponic system in a lot of areas. And so that's where you need to be much more imaginative about getting that soil condition fixed, being more thoughtful about the kind of plant material you've selected, creating the right kind of expectations for homeowners for it to be more appropriate to the soil conditions and the weather conditions that you're going to have. So that's the challenge, and that's the challenge with developers, because it's a different look. It's not the conventional look that we've all become accustomed to in master plan communities today.
Green St. Augustine grass as far as the eye can see, with palm trees,
right,
and some rectilinear ligustrums and lower pedilums, trinettes. That landscape uses a lot of water.
Lots of water. In fact, in the typical development being built today, more than 50% of the water going to a household is going to go for landscape irrigation.
More than 50%.
More than 50%.
What are we talking about, 55%?
In some neighborhoods, top of the world, I was told by the managers down there that they were using 60% or more of their water was going for landscape irrigation. And at that time, by the way, that was potable water. That wasn't reclaimed. And they were actually running into problems. They had their own water utility at that particular project, and they were running into problems with their consumptive use permit. So that was a one-to-one. They couldn't go to the local public utility. It was their private utility that was supplying the water. And so if the water management district says, that's your budget, that's it. And if you build your first 7,000 homes and you're on track to effectively run out of water before you can build all the homes that you're entitled to build, well, that's a direct threat to the business model of the project.
Because they will not be able to realize the potential of their entitlements.
Correct.
They may have 10,000 or 15,000 homes permitted. Their pro forma as a developer and how they're going to justify their investment.
Right.
And how they're going to make their profit is based on building all those lots. In fact, I would imagine that they don't actually start making money till the end, and they make all their money at the end.
That's right.
So they're at risk of not being allowed or able to build those units which they're banking on.
Every development's different, but most developments are pretty heavily leveraged in that way, and it's based on borrowed money. Or invested money, right up through 2008, when the housing finance crisis occurred, the primary investors in Florida land developments were insurance companies, pension funds. CalPERS out of California was a major investor in Florida land development projects because they were very good yield, very good return, very predictable and steady. That has been blown out of the water because of what happened. Collateralized debt, that's not nearly as secure anymore. So now I think the model has to be much more cognizant of threats to the model.
Okay, so you're saying that now investors and developers in Florida are really tuning in to potential threats to their financial model.
It's a risk.
And water is one of those threats.
Water is a threat. If they were to run out of water before they had finished building out their lots, then as you pointed out, in a highly leveraged situation where the real profit is coming in the last homes and last neighborhoods built. And there are other things. If you're a developer and you're working with an owner of a project, and if there were environmental consequences or if the water use directly threatened things that were on other properties that owner might have, I mean, there are other good reasons, stewardship reasons, that a developer would want to maintain a good reputation in this realm.
Sure, there are good stewardship reasons and reputation reasons, but I don't think that's going to get.
No, it's not.
That's not going to get the developers to necessarily change their business practice, but a financial threat.
Financial threat
does get them to change their business practices, and that is why we're having some success. And PREC, Project for Resource Efficient Communities, is really having a lot of success here in the past 5 years in convincing large-scale developers to modify their land development practices?
Absolutely. That has been a wonderful thing for me personally to see that happen, because that's what we've been working toward. At least in my career, that's what I've been working toward. So I'm very happy to see it. And I mean, what you're alluding to is the Sunbridge project. Tavistock is the developer of that project, and massive project in Osceola County, eastern part of the county on the border with Orange County. So it's a very centrally located project and right in the heart of the realization that we could run out of available water. Central Florida Water Initiative, that's what it's all about. So here they are, right in the heart of where continued growth and continued pumping of water could create a problem in the future. And so this massive project, 27,000 acre project entitled for 33,000 dwelling units. And they're at the very beginning of that. That's the developer, I think, that realized, because they've got more than a 40 or 50 year build out, they're not going to be building that last home for 40 years, 50 years.
They're thinking long term.
They have to, yeah, they absolutely have to. And even though the whole crew of people that are working there will be retired or dead before they're building that last house, but their obligation to the organization is to make sure that they're financially viable going forward. I mean, I think that must be part of their thinking. And so that's been a huge opportunity to work with them in identifying how that demand for water can be greatly reduced. And I got to say that another piece to that is we talk about the program for resource efficient communities, and that's the University of Florida. And of course, we're research oriented, we're academics, and we do get out in the real world. The University of Florida is a land grant university, and we have an obligation to take what we learn at the university and share it with people in the state. But the success that we're having in that realm has really been more about the partnership that's been developed between the University of Florida and industry, which of course Cherry Lake is a major player in that realm, and then Dix Height as a landscape architectural firm, and I would also say other universities like the University of Central Florida, Stetson University. I mean, we're having a great opportunity to pull this collaboration together, but the main thing I wanted to say is that it's between that public sector, university, and even government participation, but with the private sector able to really validate the financial aspects of it. I mean, we would not be ever in a position to bid a job. So that compost cost that we talked about earlier and how that fits into these alternative landscapes that could use a lot less water, who would truly bid that job? Who would bid that next 1,000 home project and be able to bring it in within budget and profitably? That we need real private sector partners with that on the line, because the developer ultimately will not believe the University of Florida. They ultimately understand, in their heart of hearts, they know we're academics. They know that we're not at risk, that we are actually public employees with a steady paycheck. Whereas when they're with a private sector company that has to make a living and also build a model that's replicable, that partnership is what's essential. I think the key role that we've been able to play in this partnership, the university has been able to play, is data. I think that a lot of people don't have the data that they need, and the simplest part of that data realm that we've been able to mine is metered water data. And interestingly, in the Sunbridge project and a lot of projects being built today, almost every home is a dual metered home. So they put in a meter for the reclaimed water, which is for irrigation, and then they put in a meter for potable water, which goes to the household. So now we know exactly how much water is going for irrigation. And there's that data can now be shared with the people who are responsible for the design and for the installation and for the management of landscapes. We can actually begin to calibrate exactly what the water requirements are, and not only on day one and not only during establishment, but what about year 3? A properly prepared soil with properly selected plant material, properly managed, year 3, you would expect those plants to be settling in and not require ongoing irrigation. At least it can be reduced over time. So once you have that model in place, and now you can bring that model back to the developer and say, well, here's your actual water demand for your next neighborhood. Here it is, 3 years out, here's the steady state demand from then on out. Now that developer has the real knowledge that they need to refine their business model. And that's what gives them reduced risk. At least that's what I'm anticipating will give them reduced risk. The cost, though, that's other data that we, the university, can't provide. We come back to the company that will contract to do the landscape maintenance. What does it cost to maintain those landscapes? And what are the inputs? Ongoing top dressing with compost, ongoing addition of mulch materials. We need to have those costs nailed down so that there's the first cost and then there's that ongoing repeating cost. To be honest about it, at some point the developer doesn't care because that becomes a homeowner cost. But they care in the beginning because they don't want to paint somebody into a corner, or if it's a big project that's going to have multiple neighborhoods, they don't want people going on Facebooks and complaining about what was done in a prior neighborhood. So that's the kind of information that we will get from the private sector partners that we have. And so that's where, through the outside collaborative, being able to partner with all these folks. I meant to mention Life Soils earlier, the compost manufacturer. There are just these key partners that without them, the University of Florida and the Program for Resource Efficient Communities, we could not have anywhere near the impact that we're having. And, that's just been good fortune. But it's also because it was Darren Midlane that taught me about the biology in compost. I mentioned earlier that I've been slowly realizing that it's not just water holding capacity, it's the biology. I'm educated by him. He asked me to come participate in a panel at Compost 2024, and I got to sit there and listen to him talk about the biology. So he's educating me, and then I got up and was able to talk about metered waters.
Yeah, we're all learning a lot, and we're learning from each other. I think that the collaboration has been vital, and the data is the language that unifies us.
Yeah.
A developer, private business, a farmer looks at data because we need to be able to manage our risk. We need to be able to manage our capital. We need to be able to understand our P&L and to make pro formas that help us to project and anticipate cash flows, cost, and risk over time. And we do that with data.
Yeah.
And when we don't have the data available, then we have to go off of the gut, the intuition, or sometimes we proceed in the dark. And that's never good from a risk management standpoint.
Correct. Yeah.
The larger the investment, the more important it is to manage the risk. And these large-scale developments are massive investments. And so I'm very confident that there are very sound and brilliant risk managers who are involved in those efforts, and so they respond very, very positively to data, and also I think from the standpoint of homeowners, consumers, and just people who are managing landscapes in the day-to-day, having the data is a way to create a feedback loop, so that we can adapt our practices and our behaviors as we are able to receive the data and observe how our practices and behaviors are affecting the outcomes that we're trying to impact. So in the case of water, if I don't know how much water the landscape is using, how could I possibly optimize my landscape practices to reduce water? The university's role has been fundamental, and I really think that you've been visionary and instrumental in reaching across the aisle, in escaping the ivory tower, and bringing the resources of the university to bear in a really meaningful and practical way in the private sector, working with the developers as you have been for decades, and working with companies like Cherry Lake and Life Soils. That's an important step because it doesn't always happen in an academic or university context. And there is, as a result, a little bit of suspicion or distrust, as you were alluding to earlier, that, well, these university folks, they have tenureship and they have pensions and they're not in the real world. So they might just be, they might just be over there in their ivory tower trying to push some idea that sounds good, but it's not practical. You've come out into the real world, we'll call it, and help build those bridges.
Yep.
And make those connections. I think that has been very important, and I believe is one of the reasons that we are here today, now able to significantly affect the land development practices and the landscape practices at a large scale, which I believe is going to be very important for Florida moving forwards. Because if we continue to follow the same practices, the same land development practices and the same landscape practices that we have been following for the past 30, 40 years, at the rate of population growth and development that is still happening now and will continue most likely to happen for the foreseeable future. If we continue with those same practices, we're screwed.
Yeah.
I could have used a different word, but we are definitely, we are running off the edge of the cliff from a natural resource perspective. And making those changes are important, and it's very difficult to get anyone to change, and especially large developments who, because they have such a large stake at risk, they're managing very large budgets, it's very risky to change something.
Yeah.
You have to be certain that it's going to work, or at least you need to have really compelling reason to change and a lot of data on which to rely to guide you as you make that change. And that's what I'm seeing happening over at Sunbridge.
Yeah.
And believe that there are other large-scale developments that are coming online that are looking at what's happening there, listening to you and the Project for Resource Efficient Communities, listening to the Outside CoLab and other groups around the state who are singing now, in unison. And they are ready to make the change. Yeah. They are ready to take the risk to change their landscape and land development practices. Probably because of the reasons you were talking about, if they run out of water, they can't develop the lots they have entitled, then they won't be successful financially. That's probably the main driver. But I've observed that, these developers, for the most part, they're Floridians too. Yeah. And, some people will demonize them and quickly, paint them and put them in this camp over here. But what I found is that they care about Florida as much as you and I do.
Yep.
They just happen to be building homes for people, which is a needed service. So if they start to see a path that is fiscally responsible, financially sound, that is supported by a university and the private sector, that allows them to do the right thing for wild Florida, for natural Florida, for our environment, for natural resources, they actually are really inspired and motivated to do that. And so we can all find common ground and be inspired together to do this work, because at the end of the day, it is about protecting our natural resources and protecting Florida for future generations.
Yeah, and I just picking up on what you said earlier, it's interesting. In the same way that we might have presumed that developers are driven solely by the dollar and the financial model, and that they are willing to sacrifice allow environmental consequences in the hunt for the extra dollar. Sometimes we can lose sight of the universities also are on a particular stage. We are ranked, and it's all the time. U.S. News and World Report, I think, got this all started, Newsweek, others. but we're ranked. And one of the key rankings that they use is how many refereed papers. They even take the journals that we publish in, and they're called impact factors. So now, not only do you have to publish in a journal that has a high impact factor. And now we have a new process that's been added to the university called post-tenure review. And you should see how many articles I'm supposed to publish if I continue in the university. It's amazing of course, that's all because we want to be a top 5 university. Now,
being good at football and basketball is not good enough?
Well, recently at Florida, no. but the point I'm trying to make is that if you want to get into those journals, then you follow the protocols and the procedures. Whereas what we need to do with the developer is the applied research on site, which we refer to as living laboratories. You've heard us use that phrase a lot. And the purpose is to let the developers see for themselves. And the perfect example is the boundary planting at Sunbridge at Base Camp, where we've got experience now with a whole group of native plant materials that are rarely used in residential landscaping. And we planted them there first. The developer got a chance to look at them and see how people reacted to them and see how they prospered and even see how compost affected their well-being and see how irrigation patterns affected their well-being, because it was an actual research project. But from the point of view of the researchers, it was awkward because it wasn't that highly controlled, easily statistically evaluated with a hypothesis that could be tested, and it was not easy. But if we'd done it the other way, it would have extended the process 2 years. It would have been a journal article in language and with that the developers are not going to see. They wouldn't. It's not going to be the same as walking into this experimental plot and seeing the plant material with your own eyes, seeing the difference, seeing the numbers of pollinators, seeing the height, the number of flowers. So that, to me, that whole concept of the living laboratory has been huge from that extension perspective. That land-grant university, bring the knowledge out to the developers, bring what we know about this, test it in front of them, let them see it with their own eyes. Now they can make a decision. Yeah,
and I think that's really the mission of extension, is to be embedded in the real world, working with farmers, but also working with developers. But you're right, we're all trapped in a framework of incentives.
Yeah.
And oftentimes it takes, it's hard to break out of that framework, that paradigm.
Yeah.
It takes a lot of courage. It takes a lot of vision and creativity and daring to do that. But if we don't get out of that framework, in a sense, we're doomed, because we are going to be led to continuously repeat the same patterns and practices that will lead us to ruin. And when I say ruin, I mean the exhaustion of our natural resources, the depletion of our ecosystems, the disruption of our corridors, the extinction of species, and a variety of really dreadful consequences that are easy to imagine for the state of Florida, given the pressures of population growth and what we know about the natural resources and ecosystem capacity. So we have to break out of the system, whether you're the university, whether you're the land developer, or the landscaper. And it's very hard to do that. And I think that's why I'm so inspired by what is happening right now with the outside collab, with Sunbridge, with the work that you've done at PREC. We are trying to think differently about the whole system and zoom out to understand how we can solve this very challenging problem of the future of Florida and the sustainability of Florida. And it's not an impossible problem to solve, but it requires a new perspective and a new paradigm. So we're trying to change the paradigm, and that's something we can only do together.
I agree completely. And I'll say a couple more things about that. That living laboratory idea, and having private sector partners, there are other barriers, what you referred to as finding the developer that will take the risk to go with these alternative landscapes. It's funny because it's not the risk that we thought it was. I mean, I think we keep, as we are in the living laboratory, actually doing it, like install those alternative landscapes and see what happens. We didn't realize what problems we were going to face. I mean, I think you'll agree that a year ago, 2 years ago, when we first started doing those landscapes at Sunbridge around the model homes, we took what we were seeing in the boundary planting, and that looked satisfying, and the developer said, yes, let's try that around the model homes, and the developers got the builders to kind of agree, and so we got a few homes, few landscapes to try this on. We all thought that the problem was going to be the homeowners resisting.
That has not been the case.
It has definitely not been the case, and we didn't know that. We honestly didn't know that. We also assumed that by putting in those drought-tolerant plants and everything, that the water reduction would take care of itself. Didn't happen.
Not immediately.
With the data had to flow, the landscape management folks had to kind of begin to realize that data was telling them something, and that they could respond to it, and even realize that there were many landscapes that were being so overwatered that it was damaging to the plant material that was there. I mean, that was happening in certain instances, I think, in the common areas, I think in Western Park.
It was, and it's, I guess we're admitting to the fact that, we don't really know what we're doing here. We have a pretty solid understanding of the science and the theory that if we change our landscapes to be more regenerative, to use more drought-tolerant native plants, that we should reduce water. But we don't have a lot of practice in doing that.
No.
Because there hasn't been an opportunity to do it at scale.
Right. That's correct.
So, and that's one of the reasons I'm so grateful to the team over at Tavistock to have given us this opportunity, because it was a risk for them to take, and we were learning and iterating along the way. But we were transparent about that too.
Yeah.
And I remember telling Richard and Clint that we're going to learn as we go, but we're gonna make sure that we get this right in the end. But so let's talk a little bit about the water use, because you and I are aware of some data points that would be fun to share. So the target for the utility district there, which is the Toho Utility District, is 28 inches per acre per year. And that's just a way of measuring water use over time and over an area. 28 acre inches per year. We installed these alternative landscapes at the model homes, and then we were also comparing the water use with the traditional neighborhood that was developed across the street, which is traditional Florida, St. Augustine, palm tree landscape. The results varied widely initially, and we had some homes using as high as 150 or 200 inches a year.
Amazing.
Remember, the target was 28. But as we drove down the water use on the homes where we had full control over the chain of custody, meaning that we had the right professionals who were properly trained and committed to the project, controlling the management of the landscape and the water, we were able to get those homes down to 15 inches a year.
That's so far.
So far. And we probably can drive that even further down. So the range is between 150 and 15, which is 10x.
Right.
And the variable seems to be the management.
It's the management. It is the management. It is not the plant material. It's not the design.
It is to an extent. I think the plant material and the design kind of sets the floor as how low you can go. But if you're not managing it, you're never going to get close to the floor, regardless of what type of landscape you installed.
Exactly.
But by installing the right plants with the right design, you lower that floor very close to zero.
Yeah.
In fact, it may be zero after establishment. And so we're realizing that it's going to take an understanding of the best practices across the entire chain of custody, beginning with the land development practices in terms of how they disrupt the soil and what kind of soil they're providing in the first place to the landscape, to include also the design, what right plant, right place, using the right selection of species, which in many cases native species are going to fit the bill because they are drought tolerant and they provide a lot of ecosystem services and support to biodiversity. But it's not always native plants. For example, we spent, I think, 30 minutes talking about perennial peanut, which is not a native plant, but it achieves the desired outcomes for water conservation and reduction of fertilizers and pesticides. So if we design, correctly, then we also have to make sure that the installer, whoever that may be, is using the right practices, sourcing the right quality plant material, planting according to the design, and probably most importantly, the landscape maintenance provider, who will then have a tremendous influence over how that landscape performs aesthetically, ecologically, and what's going to happen with the water use. Ultimately, it's the landscape manager who gets to set the program on the irrigation controller.
Correct.
And that person is very important. We have to make sure that we are collaborating efficiently throughout that entire chain of custody. And it goes back to changing mindsets. We're talking about, moving from a linear mode of thinking where we think of things as in terms of a waste stream as opposed to a natural cycle where we close the loop. And here we have to think not in terms of compartments and silos where each individual professional and each individual task is isolated and optimized within its boundaries. We need to think of the entire chain of custody and the entire life cycle of that landscape and optimize for the whole system. And we're getting to a systems approach, holistic thinking, which is kind of anathema to a lot of our cultural views. We think we have to reduce things to the smallest possible level of analysis and to try to look at things discreetly. But I would insist that if we want to be successful with natural systems and ecosystems, we have to think as they do, or think in terms of systems. And that means thinking holistically about the problem, which is why the collaboration between all of these parties that you have been so instrumental in promoting through Project for Resource Efficient Communities, and now that we're promoting with the Outside Sustainable Landscape Collaborative, that collaboration is fundamental. Fundamental to solving these types of very seemingly intractable problems.
Yeah, I'd like to revisit what you said just a little bit. With respect to the landscape manager, what was critical was when Jimmy, Cherry Lake, actually began directly reading the water meter. In the beginning, he was going to the irrigation controller, and he would look at the runtime, and he'd look at how frequently the irrigation events were scheduled. That is standard protocol. That's the standard practice of a good landscape manager in Florida today. But then there's a rule of thumb about what that runtime should be. And I can remember him telling me those things, and I asked, well, how much water does that represent? How much is that? And he didn't know.
He didn't know.
On the other hand, I didn't know what the runtime was, and I didn't know how frequently you were irrigating. All I knew was how much water had been used over the course of a month. And I told him that was so similar to what they were using over that conventional landscapes. And he said, well, how can that be? And so that's when he began reading the meter himself. And he built his own spreadsheet. And we agreed on how we were going to calculate inches of water. And then he began doing that on his own. And so he would read the meter prior to an irrigation event. Now, we couldn't get down to the level of the zones but all that happened, the irrigation events were on Wednesdays. And so he would read on, it didn't matter, any day prior to that Wednesday, he could read the meter. Then after the Wednesday, he'd read the meter. He knew what the irrigation event on that landscape was in inches of water. We could roll it up into an annual. If you continued at this rate, what would it be over the course of a year? And that's when we got to that, what you were describing earlier, of 15 inches. That's where we are today because of him taking the initiative to actually read the meter and understand how many gallons of water were going onto that location and how many inches that represented. When he understood that, then he actually reduced the run times. So first he reduced the number of events because that was an establishment rate. They were getting 2 events per week, and he cut it to 1 event per week. And then he started cutting back on the run times until he got down to 15 inches. And so that's how he got there, but it wasn't me telling him he needed to do that or how long the run time be. I don't know how those systems work. All I could tell him was how many total gallons he was using and what that translated into in terms of inches and how that compared to Toho's 28-inch standard they wanted us to achieve. And I could tell him that over at Del Webb, they were using 53 inches was standard in a mature landscape. The steady state demand was around 53 inches, double.
So the conventional landscape is double the standard, and we are able through proper management practices to get to half the standard.
Right. So that's more or less what we think a steady state could be. So if you told the water utility, if you told Toho Water Authority, I can come in at half of your 28-inch Toho efficiency program standard. I'm going to come in at half that. How do you feel about that? You want to give me any kind of an incentive to do that? Because you're giving incentives for people to replace their rain sensors, you're giving incentives for people to replace their old toilets, you're doing all kinds of incentives, but I'll guarantee it. And once you can do that, and of course the beauty of that is we are now in an arrangement with Toho and the Sunbridge Stewardship District to do exactly that. We haven't said we're going to come in at 50% of your 28 inches. We haven't said that yet, but we can do it. There's no question.
We should be able to do it, and I don't see why we can't even get below that because we're just getting started. And as we were talking about earlier, this is all new even to us. We have a lot to learn still, but we've had a tremendous amount of success already. And when you think about half versus double, so that's 4x.
Yep.
We're getting close. So 4 times less water. There are a lot of incentives for everybody now because presumably a developer could build 4 times more homes. But the homeowner is actually paying considerably less. I don't know if it's linear, but we saw the difference in water bills ranging from $150 a month to $15 a month.
Yep.
That's a 10x savings on your monthly water bill.
Yep.
And if you become aware as a homeowner that you could save $135 a month just by doing something relatively simple without having to give up anything that you value.
Yeah.
That's a lot of money in your pocket.
And then on top of that, we can come back and talk about the butterflies and the pollinators and the birds, which Patrick Boland's work at the boundary planting is showing that you get lots more flowers and lots more pollinators showing up and lots more butterflies showing up with these plant pallets that we're installing, and that's the case in the enhanced the landscapes that are enhanced with compost, but not even the ones that are regularly irrigated. They're ones that are irrigated as needed. So on even a water conserving landscape, but with good soil conditions, you can get those high rates of pollinators showing up. So that's another metric that makes the homeowner kind of maybe happy to see more butterflies and so forth, and value that landscape. And in fact, something I alluded to earlier, you didn't talk about it in detail, but the homeowner association meeting, the Sunbridge, the first, Wesleyan Park first homeowner association meeting happened, and I know everybody was on pins and needles thinking that the homeowners were going to be on the warpath about the landscapes, because there are these tropes out there that, people can't do without their turf landscape. Kids, where are the kids going to play? Give me a break. First, in that particular neighborhood, there's a beautiful pocket park.
Outside.
Yeah, play outside. But I mean, it's one of those situations where, come on, baby. It's one of those situations where we we don't have the data, and when the data is constructed, again, by laboratory academics, they'll say, oh yeah, people prefer turf. Well, it's not true. And it was demonstrated clearly in that event, which ironically, there were no University of Florida people at that event. It was all private sector people meeting with the homeowners and helping them solve the practical problems. There were questions about the availability of the mulch material. There were practical questions about some erosion issues that had more to do with guttering than with the design of the landscape. And no real resistance at all, I don't think, to the concept, and an appreciation. I wasn't there, but I
was there. I was there, and I just wanted to listen and hear how people were responding to the landscapes. And you're absolutely correct. There was no resistance whatsoever to the objective and the mission and the purpose of these landscapes. They were bought in. Save water, promote biodiversity, create healthy natural systems in and around our community. Everybody was for that. It was actually, there was a lot of support for it. Their concerns were more about implementation, more practical issues. Okay, how can you help me do this so that, you know, it's easy? And that's where we have a lot of growing to do as an industry, as a whole set of industries. We have to become more efficient and more able to provide these services at scale, whether it's to provide native plants, to provide affordable pine straw and pine find distribution to these communities, or just to help them answer questions about how to take care of their lawns. Those were really the issues. They were issues about the how, but everybody was bought in with the why and the what. So I feel like that is very significant, because I think solving the problem of the how, we can do that.
I can't tell you how long that would have taken if we took the typical academic approach. We're there getting the reaction of homeowners to actual landscapes that are demonstrated to be using less water, virtually no mineralized fertilizers, minimal for pesticides, I think some herbicides possibly, but minimal. And we're already getting data to suggest that certainly on the pollinator front, getting much higher pollinator populations, butterflies, and so forth.
Well, this is one of my favorite findings from the research that was done at the Living Laboratories at Base Camp. It's that because there were plots and some of the plots had compost and some of the plots were just planted in the urban soils, the development soils. Right. Other than the compost treatment, the plants were the same. There was the exact same number of the exact same species of plants in the same area for each plot. So it was really set up as an experimental study following the best practices provided by the university, which I thought that was really interesting to be a part of that. But so what we learned was that there were, at the end, more pollinators in the compost plots because they were counting pollinator visits. But you could follow that all the way back to the compost, because the compost led to more flowers and also larger flowers. Yep. And pollinators, of course, are attracted by blooms. So there was naturally more pollinators in the compost plots. So what that tells me is that we're building biodiversity from the ground up. Literally, from the ground up. And this is also what we're learning in farming through our regenerative farming practices that we started out talking about earlier. If you invest in the soil, if you invest in the biology and the biodiversity of the soil and the health of the soil, then you are going to get this ground up effect where now you have biodiversity and health at the higher trophic levels.
Absolutely.
And it doesn't stop with the pollinators. I am a firm believer that it extends all the way to the human health and the health of the community and the health of the society and the health of the state in general. And it's a different way of thinking, to zoom in our attention on the soil, which is where, a lot of nature's energy and a lot of nature's resource comes from. I'm being attacked by nature. I'm trying to support nature, and here she is attacking me. But So for me, is very inspiring. On a scientific level, on a practical level, on an economic level, we can find ways to unlock a lot of value
Yeah.
by farming the soil and taking care of the soil. But it goes beyond that for me personally. I see that there's a real spiritual and beneficial force here. When we connect to nature and become involved in caring for nature, I think it just makes our lives that much better.
And there's one more aspect to that we are yet to explore, but we're moving toward it. And I'm thinking about as the management practices for these landscapes become fully implemented. I'm thinking about how many fewer mowing machines are going to be in those neighborhoods. I'm thinking about the noise. I'm thinking about the two-cycle engine pollution. I'm thinking about pebbles getting thrown, actual insurance. In the longer run.
Mm-hmm.
I've got a landscape person that works on a house that I have in North Carolina. They're using a string trimmer. They hit a rock. The rock hit a storm window, and the door had to be replaced, $180.
Mm-hmm.
Well, to the degree that you've changed the landscaping so that a lot of those very aggressive landscape practices with that equipment, with moving parts, is reduced.
It's almost eliminated. The mowing at the model homes.
And
the noise. Well, that's why we're doing this podcast outside. It's because I like to be outside, and we probably hear all the birds on the microphones. But if you're in a community, what do you hear? Mm-hmm. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday.
And the streets.
You hear
parked vehicles with trailers, with
large trailers parked in the street, and you hear the roar of the mowers and the blowers and the edgers. It's gotten to the point where people just accept that is the sound that they are surrounded with. It doesn't have to be that way.
No, it does not. So I'm looking forward to actually implementing the no or low mow or minimal mow landscape, mm-hmm. where those are. And the reason I brought it up was because of what you said about your personal health. Mm. I do think that background constant. To be truthful, when I hear that kind of equipment, I'm always on alert because I have farm equipment. Mm-hmm. And when you run a bush hog, you have to be careful. Mm-hmm. Bush hogs throw stuff. Mm-hmm. And so anyway, I appreciate that aspect of what we're...
There's a lot of value here. I think we can justify the shift in the paradigm and the risk that has to be taken and the investment that needs to be made. We can justify that just with the water savings. But all of these other benefits are real. And I think that's the beauty of regenerative systems. When you start farming in a regenerative way, it's slow at the beginning to build the organic matter in the soil and to start building the biodiversity back into the farm system. But over time, what happens is you start getting network effects and positive feedback loops. And eventually, you get to a point where there's this tremendous amount of value that is created. In fact, you get synergy. And I think of synergy as free energy. There's a lot of free values that start to emerge. It's not just the water bill. Now it's the beauty of the butterflies and the soothing sound of the birds tweeting, the absence of the mowers. You reduce your cost because you're not having to mow. You don't have the big trailer parked in front of the street. And then you realize that you're now part of the solution. You're doing something that is actually making a difference for water quality, for wildlife, for climate, for resilience, and most importantly, I guess you can pick what's most important to you, but for future generations.
Right.
And all of that comes on top of the water savings. And so those are regenerative systems because nature is at play. And you just kind of got to get steward and tend enough to get those network effects and those feedback loops going. And then just watch it bloom.
Yeah.
Watch it grow.
Yep. Yep. That sounds good. Sounds good.